Let's do section 9.2, page 454, number 5. Apply the stronger form of L'Hopital's rule to find the limit. And in this case, the limit is, as x goes to 0, find the limit of 1 minus cosine x over x squared. So as we've been talking all along, we have a series of methods that we use to try to solve limits. We're supposed to graph. I don't really feel like graphing today. We can substitute in. So what's going to happen if we substitute the limit in here? Well, that means that every place that we see an x, we put in a 0. So I'm going to have 1 minus the cosine of 0 divided by 0 squared, which is going to give me 1 minus, and what's the cosine of 0? 1 over 0, or 0 over 0. Now, this is all right because we can apply L'Hopital's rule. There are some other methods that we have, algebra or simplification, not really anything we can do here. And behavior modeling, again, we don't really have polynomials, so that's not going to work. So L'Hopital's rule is our best bet. Now, L'Hopital's rule tells us that what we're going to do is take the derivative of the numerator and divide it by the derivative of the denominator. So what we had was the limit as x goes to a of f of x over g of x, and that was going to be the limit as x goes to a of f prime of x over g prime of x. So let's take our derivative here, and it's still going to be the limit as x goes to 0. And if I take the derivative of 1, what do I get? 0 minus, and what's the derivative of cosine x going to be? That's right, negative sine x. And what's the derivative of x squared going to be? That's right, 2x. So just to clean things up a little bit here, I'm going to have sine x over 2x. And once again, I can substitute in and see where this gets me. So I'm going to put in a 0 everywhere I see an x. So I'm going to get the sine of 0 divided by 2 times 0. And what is the sine of 0? That's right, it's going to be 0 over 0. Well, I didn't really get an answer. Applying L'Hopital's rule once didn't really help. But because this is a limit, and that's why we're using the stronger form of L'Hopital's rule, because this is a limit, I can apply L'Hopital's rule again. So let's take the derivative of this, and again, it's going to be the limit as x goes to 0 of, and what's the derivative of sine x? Cosine x. And what's the derivative of 2x? 2. And again, I can substitute in. So I'm going to have the cosine of 0 divided by 2, and the cosine of 0 is, it's still 1, so I'm going to end up with a half. Now, I just want you to remember and really notice in this example that we took the derivative of the numerator separately from the derivative of the denominator, and we did not use the quotient rule.